So hello friend, welcome to my channel. So today I am going to discuss about next lecture means 3, and in this lectures I will solve the problem of GATE 2020 chemistry. And in this paper actually in this paper actually we have made means I made 2 videos, and this is the lecture 3. So if you have not seen my last 2 video, please go and see those video and cover all questions of proper detailed solutions. So now in these lectures I am going to solve next problem. So here the problem 1 is here given. Okay, I will read the questions. What is question saying? The question is saying in a NMR spectrometer operating at a magnetic field strength 16.45 Tesla, the resonance frequency in megahertz round means you have to find the resonance frequency which is round off 1 decimal place of this 19 fluorine nucleus. Okay, this 19 fluorine nucleus. So and here given the G value and beta n and Planck constant H. So basically here found the frequency, resonance frequency, which is we have to calculate megahertz. So first to write what things is given to us. So I have here written these things are given. We have to find the resonance frequency. So simple, we know the resonance frequency mu is actually I am calculating for 19 fluorine. So resonance frequency is equal to Gn beta n. Beta 0 means magnetic field strength divided by Planck constant. So after putting all these values we get this value and convert this value into this 10 to the power 6, which is called the mega. Okay, so this is finally converted in megahertz. So simply we put all these values and this Tesla inverse cancel out with this Tesla and joule is cancel out. So simply calculation we can get this value. Okay, now second question is basically from, as you know, the absorptions related. So second question is, I am reading, a solution containing a metal complex absorb lights at 480 nanometer with molar extension coefficients. Here given the molar extension coefficient is 15 15,000 liter mole inverse centimeter inverse. Okay, lambda value is given to us, and L's path length or cell qubit cell length is 1 centimeter, transmitters is 20.5%. C, we have to calculate C. So here the concentration in mole liter units of that metal complex, what will be the concentration? So here we apply simply formula. As you know, absorption is equal to epsilon into C into L, and actually we have to find the concentration, so we simplify this, we rearrange this formula. We have to calculate C, so C is equal to absorption upon epsilon into L. Okay, so here we don't know absorption, how much this absorbed light. Okay, so we have to first calculate absorption. Okay, so apply this formula. Absorption is equal to 2 minus log of base 10 to transmission. Actually this formula is directly I have put percentage T by 100. Okay, if you see, as we know, the transmission absorption is equal to log of base 10 1 upon T percentage. This is the actual formula. Okay, and if we put this value in T by 100, okay, here 1 divided by T by 100, so 100 goes upside. Okay, so if 100 goes upside, then what will you get? You get 100 minus 100 upon T. Okay, I simplify, you use log formula, log 100 minus log of T. So you can also simplify log 100 is equal to 10 to the power 2, 10 base 10 is equal to 1. So that's why here we written 2 directly. Okay, so 2 minus log base 10 to T. So simply we put value, because here given the percentage, so because I applied here already 100, that's why we directly put 20.5. okay, so simply value of this log of base 10 of 20.5 is 1.3, and 2 divided minus, subtract 2 minus 1.5, we will get 0.7. so simply this value you finally get absorptions, and now you put here absorption 0.6, and you have already given, you have already this mole extinction coefficient and L path length. So simply you put here, you will get finally the concentration, how much concentration of your metal complex. So now question third. So question third is basically given some options, and we have to choose which option is correct for this given butadiene, and also given the lowest unoccupied pi molecular orbital of butadiene. So here asking the correct representation about the lowest unoccupied pi molecular orbitals of butadiene. Okay, so before start this question, this types of question, first you have to roughly the x value. So if you know the x value, you can get some idea. Otherwise, if you don't have, you don't know x value, or you don't have capacity to remember x value, then you can directly and just the answer according to this. Okay, so here this first you do this. Okay, because here 4 butadiene having 4 carbon, 1 3 4, so there are 4 orbital, 1 2 3 4. Psi 1, this is psi 1 means N0 indicates there is no nodes, and psi 2 psi 2 for N1, and psi 3 for N2, psi 4 for N3. So N3, this N value is indicate how many nodes present here. So this is HOMO, and this is psi 3 is LUMO. So here they are asking about lowest anupaati. So here asking about LUMO. So this is your LUMO. So here you see for LUMO psi 3 and 2 is for, so here 2 nodes, you see one is here, another is here. Okay, so 2 node is here. So according to this you can judge the answer. So 2 node is here, first plus minus minus plus. So if you see in option second, plus psi 0 plus 0.60251 minus 0.3752 minus, so here first they have first value written plus, second value written negative in minus, third also written in psi 3 negative, and psi 4 written is plus 2. So here this is plus minus minus plus. So here you can, according to this you can choose the answer. Okay, so actually the option is B is correct. Okay, in short way you can judge the answer, but in detail first you calculate the x value, so it's very lengthy process. Okay, so method 1, first you determine the Huckel's, okay, Huckel determinant of this butadiene, this determinant, okay, H11 minus ES1, that is I am written here, just like this is actually determinant. Okay, you know, you have already read in 12th class, so this is simply determinant. Okay, and here some rules for this determinant. If HII means H11 bonding is there, okay, 1 bonding is there, then we can write alpha. Okay, and for S11 here we write 1. Okay, but if different IJ, okay, then we write the 0 if not bonding. Okay, and IJ, Sij is, we write the 0. And third rule, Hij is equal to write the beta if bonding is present. Okay, so these 3 rules you have to keep in your mind if you follow this Huckel's determinants for methods. Okay, and finally from this you put this value, you will get this types of expression, alpha minus beta. Okay, alpha minus beta, alpha minus beta type will get some expression, and after putting the alpha minus A upon beta is equal to S, okay, then you will get the value quadratic, some quadratic, tetraquadratic, yeah. Okay, so you will get some x values, so those x values we put here, because finally you will put in place of this x value. Okay, because here you let's this alpha minus is upon beta is equal to x, so you put x values. Okay, so here I am written sort method. So this ethene x value is 2 plus 1 minus 1. Okay, and for butadiene x value is 4. So x value basically depends on how many carbon is present. Okay, right? So here x value butadiene is 4 plus minus 0.618 and plus minus 1.618, and this cyclobutadiene x value is 4 also here. So here x is 0 0 plus minus 2, and this is benzene. So here for 6 carbon, so x value is also would be 6. So here plus minus 1 plus minus 1 plus minus 2, and this is allele. Okay, so this is allele. So here the 3 carbon, so x value will be also 3, 0 plus minus root 2, and this is for this x value also 3, 1 1 minus 2. Okay, so these are the thing mostly asked in several exams related these exact molecules. So in this question they have asked this butadiene. So here we can directly, if you remember these things, so you can directly put the x value in place of here, so you will get the energy. Okay, and also remember for this expression x value, alpha value is 0 and beta value is minus 75 kilojoules. So after putting all these value, alpha 0, beta minus 71, and you already know the x values for this butadiene, and you will get easily E value. Okay, so you can calculate here E value. You can also in energy states of this butadiene you can easily get, like E1, E1, E2, E3, E4. Okay, so these are the 3 questions which is very important. Now I will discuss other question. Okay, other question means okay, 1 minute as I clean this thing, then I will write next question. Actually it's very difficult. Okay, right. Okay, right. Now we see the next question. This next question is from organic chemistry, and here basically asking the peaks. So question is, okay, 1 minute. Some disturbance happened. Okay. Right. So here the fourth question is, fourth question here given the molecules and this is actually the above the plane. Okay, and this here it has O, here it has methyl, and this is given some condition NaH2 equivalent. Okay, and methyl iodide also given to equivalent. Okay, so here asking the product. So product we have to see in this direction according to the numbers of peak exhibited by the major product. Okay, so broadband protons decoupled 13 carbon NMR spectrum is so here we find the numbers of peaks which exhibited by major product. This P given P in its broadband proton decoupled 13 NMR spectrum. Okay, first we find the product, then we can get the some idea of these peaks. Okay, so first you have to write the product. So product is here actually given the 2 methyl group. Okay, 2 methyl. So here the reaction will happens, the product will form product is from if you know the product, you can easily find the peaks. Okay, so product is something like that. Here 2-methyl group. Okay, and so here basically we see the numbers of types of carbon, because here given the 13 carbon NMR. Okay, so how different types of carbon is present. Okay, so if you see from here, this is same carbon. Okay, so this is same carbon, and this is another type of carbon. Okay, and this is another C, this is D, because this C attached here for this carbon, here methyl, and here two same, but here we write C, and here the D, because here another carbon attaching with different group. So this is D, and this is E. For this carbon is E, and for this carbon is F. Okay, and for this methyl is G, because both methyl are same, so we write only G, and this is for H. Okay, so total how much? 1 2 3 4 5 6 7 8. So here basically 8 types of carbon, 13 carbon NMR peaks present. Okay, so this is the answer. This is basically the theoretical question, not optional. So here the 8 will be the answer. Okay, now we move to the next question. So next question is basically from so next question is, assuming no interaction between vibrational and rotational energy level in HF, the frequency in centimeter inverse, which is, we have to find the frequency which is centimeter inverse round of nearest integers of R branch line origin from Z is equal to 4 and its IR spectrum is. So here we have to find the energy difference we have to find. Okay, so here given the mu values, mu 0 and rotational constant for HF. Okay, so basically so question question 5. So here given the J values 4 and rotational constants is given to us is for HF is equal to how much? 19.35 centimeter inverse, and mu 0 is given to us 14.13852 centimeter. Okay, these values are given to us and we have to find the delta E's of this. Okay, so interaction between vibrational and rotational energy level in HF, the frequency centimeter. Okay, so now we find. So simply we apply the formula. So this is rotational constant is basically B. Okay, so B is given this. So actually we know the formula delta E R is equal to mu 0 plus 2B J plus 1. Okay, so we put all these value. Mu 0 is given 14.138.52 centimeters plus 2. B is given to us 19.35 centimeter inverse, and J is given 4 plus 1. So you can easily calculate, then easily get the 4332.02. Okay, so you have to you get this interaction of energy, okay, of this rotational. Okay, right. So here is R branch line originating this spectrum, and so this is the answer for this question. Okay, once I check what is the answer. Okay, this is the correct answer. Okay, so our branch of vibrational and rotational spectrum in IR region appears this. Okay, delta AR is called to this. Okay, hopefully you understood. Now next question. So next question is 5, 6. They are given to some values. What value is given to us? Here question is, I am reading the total numbers of G parallel line expected in the EPR spectrum of the solution of bis salicylate LD-amine, okay, copper. Second, having pure 63 copper and 14 N at 77 Kelvin is okay. So here we find the total G parallel lines, okay, of this molecule, okay, bis salicylate-amine copper. Second, okay, and some value is given to us. I value, this copper 16 copper, I value is given 3/2, and this 14 N I value for nitrogen, I value is given 1, and this hydrogen 1H given to 1/2, okay. So we have to find G parallel line for this bis salicylate-amine copper. Second, okay, so first, if you know the structure of this big molecule, then you can get the idea, okay. So it's very big molecules I am writing here. So molecule is like this. Here first benzene, and this C double bond N, this copper, and this oxygen, and this copper, okay, and again this oxygen, this. Actually this is very big molecule, okay. How people know? Only organic people maybe remind, okay. I don't know, I am not much about organic in detail, okay. That's why for me is big challenge, okay. Another benzene is here, okay. So this is the actual structure. So this is the actual structure. Okay. So see, this is the actual structure of this bis salicylate. Actually I feel very difficult to read these names, okay. So if I don't know much about this name, then how can I remember this structure of these molecules, okay. Anyway, but so how to find the G parallel line, okay. So simply we apply this. Okay, so simply here apply multiplicity 2n I plus 1. This is for, okay, actually here given the copper, nitrogen, hydrogen. Okay, so here asking the G parallel line for this. Okay, so here given one hydrogen for this, actually this is EPR. Yes, yeah, EPR. So here this is not NMR. Okay, so this means what I can say, separately these species copper, nitrogen, hydrogen will affect. Okay, is separately, not means affect with surrounding. Okay, so this is for copper and into 2n I plus 1. This is for nitrogen and 2n I plus 1. This is for hydrogen. So simply you put all these value. Okay, so copper is here 1. Okay, so copper is 1 and second oxidation cascade. So here total numbers of line G parallel line, okay, is equal to, so copper is 1. Okay, 2 1 into I values for copper is 3/2. And plus 1 this into this for nitrogen. So here nitrogen is affecting 2, so 2 is nitrogen here is present. Okay, so 2 into 2 and I value for nitrogen is 1 plus 1 into 2 for hydrogen. So here 2 is hydrogen affecting, you see 2 hydrogen 1 2. Okay, so here hydrogen will also affect 2, so 2 into 1/2 plus 1. So simply solve, this 2 is 2 cancel out and this 2 is 2 also cancel out. So here you will get 4 multiply here you will get 5 and here you will get 3. So 60 total lines, G parallel lines is 60. Okay, so this is the total lines. So 60 G parallel lines will get for these molecules. Okay, right. Now next question is asking the correct combination L1 L2 among H minus NO minus MECH2 minus. Okay, this is very simple, and first you calculate the, I will tell you this is very simple questions. Okay, so we are basically given so question 7. So here basically given the So ligands value L1 and L2 values is given. H minus, NO minus, and this methyl CH2 minus. Okay. So by choosing these four molecule species, we have to, by using these given molecules. Okay. So here rubidium and this L1, L2, this is 5-member ring. Okay, and this side also 5-member ring. Okay, and this side also carbonyl, and this side also carbonyl. So from this, first you have calculate total valence electron for this ruthenium and for this, not only for this one. Okay, because both are same. Okay, so for this 5-member ring contribute 5 electron, plus ruthenium contribute how much? Ruthenium how much contributing here? So ruthenium contributing is 8. So I am contributing 8 and carbonyl contributing 2. So I am leaving here 3 things. Okay. So how much? 15. So for this 15, how much required? You have to require 3 electrons for fulfill this octet. Okay, so here we choose these 4 ligands. Okay, so we have to choose L1, L2 values. So which will from these ligands which will favorable for this complete this octet, means we have to find total 18 electrons from this. So if we choose L1 is okay. Here I am missing something. Okay, wait, once I check. Okay, sorry. Once more is given. NO minus. CO is also given. Here NO minus CO. Okay. So here CO is also carbonyl is also given. Okay. So if we put this, we take L1H minus, is it this H minus possible for this place? Because I never seen H bonding with share 2 electron with other 2 bondings. Okay, so this is not possible, and this NO is also not possible. Okay, and Me this 2 minus. Okay, so here if you see Me